Today we're going to be doing 3-5. We're only going to do part 1, which is solving polynomials using division. We are going to find all of the zeros of the polynomial. That means both real and imaginary. So let's review. A real zero is any type of zero that does not contain I. Remember, I is our imaginary unit. So real zeros can be broken down into two types of zeros, rational and irrational. My rational zeros are whole numbers, terminating decimals, and or repeating decimals. Simply put, an irrational zero is any zero that can be written as a fraction. Whole numbers, terminating decimals, repeating decimals, I can all write them as fractions. So I want to skip over to the little chart. These are common rational zeros. When we use our calculator to find zeros, it gives them to me in decimal form. So we need to take that decimal and put it in a fraction, so then we can take our zero and put it as a factor, because we need to be able to switch between the two. So let's remember, 0.5 is 1/2, 1.5 is 3/2. 0.3 repeating is 1/3, 0.6 repeating is 2/3. 0.25 is 1/4. 0.75 is 3/4. 1.3 repeating, that's really 1 and 1/3, so that would be 4/3. 1.6 repeating is 5/3. 2.5 is 5/2. And 3.5 is 7/2. Those are some of the common rational zeros that we're going to see. Now, an irrational zero, then, on the other side, is zeros that are non-terminating decimals, non-repeating decimals, or a number that contains a radical. And remember, that is the little square root symbol. Okay. So for example, square root of 3. There is no way that I can rewrite that as a fraction. Therefore, it is an irrational zero. Square root of 2, square root of 5, the number pi, that is an irrational zero. So imaginary zeros are zeros that contain the imaginary unit I, where they do not touch the x-axis. That is why we call them imaginary, because I cannot see them. But they are there. Okay, so let's take a look at our rules. So steps for finding all the zeros when given a graph. So today I'm going to give you the graph. Tomorrow you're going to have to do the graph on your own. But today when we give you the graph, you're going to look for all your rational zeros. I always start with my whole numbers. Make sure you account for the ones that have a multiplicity of 2. Remember, that's where they just touch the line and turn back around. We're then going to use synthetic division to divide out all of our rational numbers, or zeros. And remember, your remainder should be 0. That's what it means to be a 0, is you have a remainder of 0. And also remember that your zeros are the C value that goes in the box. You do not have to change your sign because we are not giving factors. We are going to repeat this step until we get our function down to either a linear or quadratic function, because I know how to solve both of those. If you can only get it down to a quadratic, you will have to use the quadratic formula. And remember, when listing all your zeros, remember that your degree equals your number of zeros. And that's usually where I start, figuring out how many zeros I have and how many I need to find. The other note that I need to tell you about is that all radicals and i's come in pairs. So if I have a 0 at the square root of 3, I also have a 0 at a negative square root of 3. If I have a 0 at 2i, I have one at negative 2i. They have to come in pairs. We cannot have just one. So let's start looking at example 1. We're going to, given this graph, find the number or find all my zeros. If I look at my highest exponent, it is 3. Therefore, I have 3 zeros. So first thing I'm going to do is draw 3 blanks. I know I will be done when I have filled in all of my blanks or my zeros. Okay, since this was a degree of 3, that means 3 zeros. So I'm going to look at my graph. I'm going to look, do I have any whole numbers? I do, right here at negative 2. So I'm going to use that as my first 0. The other 2 are not whole numbers, and I am not exactly sure if they are halfway between or not. So I'm going to just use the negative 2. Knowing that will put me into a quadratic, and therefore I can solve from there. So I'm going to put a negative 2 outside of my box and my coefficients. Since there is no x squared term, remember I need a 0 as a placeholder. And remember, we bring down the first and then we do the multiply add until I get to the end. I came up with a remainder of 0, so that's good. That means this started off as an x cubed. This one will now be an x squared. So I have the polynomial x squared minus 2x minus 1. That is not factorable. Therefore, this is going to be a radical, and I need to use the quadratic formula. So we're going to bring it over here, and we're going to solve using the quadratic. So it's x equals negative 2 plus minus the square root of negative 2 squared minus 4 times 1 times negative 1 all over 2 times 1. So if I simplify, I get 2 plus or minus the square root of 8 all over 2. Okay, we know that 8 is really 4 times 2. So when I simplify that radical, I get 2 plus or minus the square root of 4 is 2, and the other 2 stays inside, all over 2. And now I reduce. So I get 1 plus or minus the square root of 2. So my other two answers are 1 plus the square root of 2 and 1 minus the square root of 2. I do want you to list them separately because I want you to put the blanks and I want you to fill them in. Okay, let's look at 2. This has a highest exponent of 4. Therefore, I am going to have 4 zeros. So I'm going to start by drawing 4 blanks. So let's look at my graph. Okay, this is the easiest one. I see one at 3. Okay, I need to find one more. The most blanks I can have left for me to solve is 2. Because that would get me to a quadratic. So I need either 1 leftover blank or 2 leftover blanks. So there has to be another one here. And so the only other one I see is this one. And I'm going to just assume that is a -1/2. Because it looks to me like it's halfway in between. If I don't get a remainder of 0, then I'll know it was wrong. And then I could go to my calculator and type it in to see if I can get something more exact. But let's give it a shot. So I'm going to start with my first 0 of 3. I'm going to put my coefficients. And I'm going to go ahead and bring down. Yeah, remainder of 0, so I'm good with the first one. That's my check. And now I'm going to move to the other one. So I said it was -1/2. Again, I'm going to use my depressed polynomial, so I'm not going to bring down the last column. And I'm going to start with my multiplying and adding. It does get me a remainder of 0, so that one was good. So now I see what I have left. So it started off as an x to the 4th. This is an x to the 3rd. Therefore, this is an x squared. So I have the polynomial 2x squared plus 8x plus 14. I always want to look to see, do I have a greatest common factor I can divide out? And I can. I will every time I have a denominator here. So I'm going to divide by 2. It will make the calculations easier and less simplifying in the end. So from here, we're going to go straight to our quadratic formula. So it's x equals -4 plus or minus the square root of 4 squared minus 4 times 1 times 7 all over 2 times 1. And now I'll simplify. So I get -4 plus or minus the square root of -12 all over 2. Remember, -12 is really -4 times 3 because I want a perfect square. Let me wait up for my writing to catch up. Okay, now that it's caught back up, remember -12 is really equal to -4 times 3. Because I always look for the biggest square root or perfect square that divides into. So when I simplify this, it is -4 plus or minus, the square root of -4 is 2i, and the 3 stays in, all over 2. Those are divisible, so I'm going to go ahead and divide. I get -2 plus or minus I square roots of 3. And so I'll write those as two separate answers. Negative 2 plus I square roots of 3. And negative 2 minus I square roots of 3. Okay, from here we're going to go on to the last example. So if I look at example 3, we will notice this is a 5th degree polynomial. Therefore, I need 5 zeros. So I'm going to draw 5 blanks. On your assignment, this is the first thing you should do every single time, is draw blanks for all of your possible answers. So let's look at my graph. I have a 0 at negative 4. I have a 0 at negative 1. I have a 0 at 2, and since it just touches the line and goes back in the direction, I know that happens twice. And I'm not sure about the other one. It looks like it's at 0, but it also looks a little off. So I'm just going to hold it. I know this will get me down to a linear, so I'm going to go with what I have. So I'm going to start with negative 4. And I'm going to put my coefficients. And I'm going to go ahead and bring down and start the process of multiplying and adding. Remember, we multiply what's on the bottom to the box, and then I add going down. And remember, since it is a 0, my remainder should be 0. Okay, next I'm going to move on to 2. In the order I do these zeros really doesn't matter. It's just whatever you come to next. And again, it should be 0 because it is a 0. And I had 2 twice, so I'm going to go ahead and do 2 again. I'm using my depressed polynomial each time, so my row is getting shorter each time. And finally, my last 0 that I think I found is negative 1. And it was 0, so that is correct. So now I just need to figure out where I am at. So this first one was an x to the 5th. So x to the 4th. X to the 3rd, x squared, and x. So what I am solving is 7x minus 1 equals 0. So x equals 1/7. That is my last 0. Okay, that is it for today's lesson. If you have any questions, please email me, and I'll be back again tomorrow.